Good morning, students. Now, in the last lecture, we have discussed about the pipelining hazards. So, let's discuss the pipelining hazards into details. Uh, first, pipelining hazards. So, it is a situation that prevent the next instruction from executing. That means it is a type of barrier or obstacle that is preventing the next instruction from execution. We don't allow the next instruction to get executed. So it is a type of barrier in the that decrease the performance of the pipelining. So there are three types of pipelining hazards. The first one is control hazard, the second one is structural hazard, and the last one is data hazard. This structural hazard is also known as the resource hazard. So, and there are three types of data hazard, that is RAW, read after write, WAR, write after read, and WAW, write after write. Please note here, we will discuss this in details in this lecture only. Please note, this hazard, data hazard, always arises when there is a write operation. So the first one also contain the write operation, the second one also contain the write operation, and the last one also contain the write operation. We will discuss in details in this lecture. So first, coming with the control hazard. By the term itself, control hazard, that means something is preventing the next instruction from getting executed because of control. So what is this? I have written here. Control deviates from normal execution. Control control deviates from normal execution. That means the control is not moving as per my expectation, what is defined. This is because of the branch instruction. This is because of the branch instruction. How we will see this? So let's say there are 5 number of instruction. Instruction 1 will do something, instruction 2 will do something, 3, 4 and 5. In instruction 3, I have written go to instruction 5. That means instruction 3 is saying, please saying the control to go to instruction 5. That means skip off instruction 4. So see this space time diagram I have drawn for you. So there are 5 number of instruction, and all these are the clock cycle 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have discussed in the class in the earlier lecture also. And these are the 4 stages: fetch, decode, execute, and memory write back. So instruction 1 FDEM, instruction 2 FDEM, 3, 4, and 5. So instruction 1 is executed by 4 stages FDEM. After clock cycle 4, it is completed. Instruction number 2 after 5 clock cycle completed. Instruction number 3 FDEM. Fine. Just see, instruction number 3 is saying to go to instruction number 5. So when it will go? So instruction number 3, fetching is done. After the decoding, after decoding, the processor or the system came to know that you have it has to execute the instruction number 5. That means at execution part, it the control is going to the instruction number 5 at execution part. At clock cycle 5, please see the instruction number 4 has already started the fetching part and the decoding part. That means fetching and decoding of instruction number 4 has already done at clock cycle 5. But the execution of instruction 3 at clock cycle 5 is saying go to instruction number 5. That means this I4 instruction 4 fetching and decoding become useless. So what I have written, all prefetch instruction become useless. So this FD fetching and decoding become useless because that time the control is moving from I3 to I5. So fetching and decoding of instruction number 4 is not required or become useless. So it can shift to this fetching can be shift to from clock cycle 6. It can be start from after 9 also. So for the time being, what is my concern, that if this because of this branching instruction, the normal pipelining performance is degrading. Why it is degrading? Because of this. Now if the instruction number 4 does not start from clock cycle 4, it will take more time. When it will take more time, that means the performance is degrading. So this is hazard. What hazard? Control hazard, because of the control and because of branching instruction. Now coming to second, structural hazard. This is what I have told earlier. This is also known as resource hazard. So that means same resource is requested by more than one number of instructions. Take a practical example. Let's say 2 students from your batch has arrived me and for some query. That means I can solve your query one by one. I cannot solve at the same time. Same thing happens here. Resource hazard. Same resource is requested by more than one instruction. See, F and M, that is fetching and memory write back. That means for the fetching, memory is access, memory location where the instruction is stored. And for memory write back, again, I am storing something at the memory. That means this fetching and memory write back are accessing the same memory not same memory location, the memory location, certain memory. That means both access memory location. So only one can be executed at a time. Because both this fetching and memory, that means I can access the memory one at a time. Similarly, this fetching and memory write back can be done one at a time. So see this example I have written. FDEM instruction 1, 2, 3, 4. These are the clock cycle and these are the stages. FDEM, fetch, decode, execute, and memory write back. See this. At clock cycle 4, memory write back of instruction 1 and fetching of instruction 4. That means M and F both want to access the memory location, but only one is allowed. So if this is allowed, this will be delayed. If this will be delayed, that means starting from clock cycle 4, it will start from clock cycle 5. Again, see, at clock cycle 5, this again instruction 2M and instruction 4F, this again want to access the memory location. Again, this is delayed. This is again passed to this. Again, here it is delayed. This is passed to this. Again, MFR not allowed. So this fetching is now starting from clock cycle 8. Why? Because of resource hazard. Same resource is requested by more than one number of instructions. M and F, that is the memory location. More than one instruction, that is instruction 1 and instruction 4 want to access the memory. So only one can be accessed at one time. So there is a how many clock cycle are lost? The F is starting from 8 and expected starting is 4. So 1, 2, 3, 4. Loss of 4 clock cycle. So that means loss of 4 clock cycle means loss of time. So the performance is getting degraded. So this is because of structural hazard. Now the coming to the last one, that is data hazard. Please note this is more important as compared to the other two. Data hazard, we have discussed in the class also. Inter-instruction dependency. That means one instruction is dependent on the other. See, I have written one instruction depend on the result of the previous instruction. That means instruction 2 is waiting for the instruction 1 to get completed because instruction 2 is dependent on instruction 1. So there are 3 types of data hazard. The first one, raw, that is read after write. That means the first instruction will write, then after the second instruction will read. So for to explain this, I have taken 2 instructions. Let's say IJ. So I will come first, J after that. So first I will execute, then J will execute. So according to this, first reading will be done after write. That means I will write first and J then read after I reading. But what is doing that? J read the data before I write. What is my expectation? My expectation is I will write first and J will read after write. But J read the data before I write. So what is the problem? Let's see. I have given this example on the left side. 6 is stored in R1 and this is instruction I and J is what? R1, that is the content of R1. Here R represent register. So the content of register 1, that is nothing but 6, is added with 3 and is storing in register 2. So see this FDEM, FDEM for J. That means this J instruction have to wait till I complete, because J is dependent on R1 and R1 is a part of I. So see, until memory write back of instruction number I, that means I is storing this 6 into register R1. So memory write back is required. After that, the J will start. But see, this decoding of J is done before memory write back of I. That means the J is getting the different value. What is the expectation? J will get the value of R1 as 6, but 6 is stored at here, M part. But before 6 get stored, the J is already reading the value, decoding, already reading the value. So J will get a wrong value. So this is part of data hazard, that is raw. Second one is WAR, read after write. The expectation is first write, first you have to read and after write. So write will be done after read. But J, what J is doing? J try to write first before it was read. So see, I have given example I and J. So register 3, the content of register 1 and register 2 is stored in register 3. Same for this. So see, R2 is acting as an input to get R3, but here R2 is my output. So here I have written 2E. We have taken one clock cycle for one time cycle, one stages we have taken, assume that. But maybe it is possible that one stage will take more than one clock cycle to execute. So let's say for the time being, this has taken 2 clock cycle. If this has taken 2 clock cycle, that means, check this part, the execution of I and this execution of J. So R1 is used as an input for I, and here R2 is used as an output for J. So this is one-sided. It cannot be possible. So this WAR is again creating the pipelining hazard. And the last one, that is WAW, write after write. That means J try to write before I write. So logically I should write first and then JJ write, but J try to write. See how the instruction number, I have forgot to write J, please write J here. The content of something is stored in R2, again the content of something is stored to R2. So see this part, again I have written FDEM, FDEM, I have taken 2 clock cycle for execution. So at this part, again both are executing. But according to the logic, what? According to the desired logic, first J will write and then first I will write and then J will write. So here both are executing. So this is not possible. So this will create a hazard, or this will create a wrong result. So now coming to RAR, why this is not a hazard? Because read after read, read after read. Let's say I have written something on the board. I am also reading, you also are reading. So we are getting all the same data. There is no point of getting wrong data because we are reading. But that data will change only in the case of writing, when we are modifying the data. So RAR is not a hazard. So that is all for this lecture. If you have doubt, you can contact me. Thank you.